Thank you again for inviting me and HyGear to participate here. I'm glad that Jose Luis already introduced deeply the project member where we participate, because my presentation will focus more on describing what we do as a company and then introduce our role in member, more as an overview, but not so much in detail. First, some comments about HyGear. We're an SME, a small company located in the Netherlands. Our main office is in the city of Arnhem. And we have two offices, one, the headquarters, and also an office in Singapore, which deals with Asia, not only sales, but also service and support to the operation of the systems in that region. We're 82, I don't know if this is the latest updated number, but about 80 people working in the company, active in 20 countries. Yeah, this is just some numbers on our gross revenue and operation installations worldwide, about 70 plants. Our business, our main product is hydrogen. We sell most of the hydrogen produced with via steam methane reforming. So this is the first system you see on the left. These are our core products. We have other technologies. The HYGEN E from electrolysis. This is a newly developed system, but still steam methane reforming, due to cost reasons, is always the cheapest hydrogen available. Is our main product, and we have two other products that are the Hy.REC and the Hy.PURE. So the Hy.REC is used for recovery of hydrogen-nitrogen mixtures, and the Hy.PURE systems for on-site purification. So what we deliver is gas via on-site technologies, being that for generation or recovery and purification. As you see in the photos underneath, these are all container-sized units, usually in 20-foot or 40-foot containers. In some applications, 10-foot container, but mostly 20 and 40. In some exceptional applications, can be just skid mounted, as you see this Hy.REC, but mostly it's on containerized units. This slide shows you a bit of the history of our company. Started in 2002. I guide you through the main milestones in this race. Let's say the first commercial system was the HYGEN 5. This is a generator of 5 normal cubes per hour. This is now already out of the portfolio because only research labs would use this, but we're more oriented to industry. In 2010, released the HYGEN 50. This is still our main product, and we sell it still until now. In 2014, we introduced a different strategy for sales, which is called gas as a service, where we lease the systems, so that we sell the gas molecules rather than selling the machine. And we are responsible for the operation and the servicing of the machine. And once the lease contract is ended, we come and pick it up. And this has been very successful. And then another important milestone is last year we started selling the HYGEN 150, and this is the largest, let's say, production in one unit, and customers that need higher volume, that 150 normal cubes per hour, just place multiple of these units on site. Something about our strategy. Let's say we envision 3 horizons for developing our businesses. The first horizon is the hydrogen generation systems, and this is what let's say keeps our income year to year. Hydrogen recovery started a couple of years ago and is going very well. And then future horizons, here's where we look, we put our interest on R&D projects. We participate in EU projects. Horizon 2020 actually even started in FP6, and we worked with many of the people here joining the workshop today. Our market, this is a graph that shows, let's say, the size of the market depending on the industry size. We're always looking at the range, most likely under 1,000 cube per hour. I could say maybe under 600 cube per hour. The float glass is our main customer, and we're getting in contact with a steel for recovery of. We're developing the Hy.REC for recovery of hydrogen nitrogen from annealing of steel, and it's a kind of modification of our Hy.REC that is already operational in the float glass industry. This is an interesting graph that shows you, let's say, the average cost per cubic meter of hydrogen, comparing from trucking from centralized hydrogen supply and using on-site generation. Of course, we are much cheaper than trucking as long as you're not neighbor to a centralized large-scale plant. Then we become cost effective. And what we tend to do is we have multiple systems. Let's say if we have multiple systems located close geographically, we use some of these as anchor customers, and we're able to also transport in if the distances are short to other end customers that we have in the area. That's why you see in this plot a combination between we can truck the hydrogen. We have our own trailers, and we have on-site generation. We have a combination, and so on. We can move to the HYGEN 150 and multiplication of units. Yeah, the advantage of on-site generation is cost saving. Say generating on site for these scales has been proven to be more cost effective. Reliability of supply, we are able to include the backup. And even in the more strongly in the HAS contract where we lease the systems, we're responsible for the supply of the molecules, and the customer doesn't need to worry about a thing. Reduced emission because we don't need to transport the gas, and increase safety because there's much less interaction of the people on site, reducing the risk of human error. I'll tell you something about the on-site generator for hydrogen generation technology. So this is our HYGEN. This is an image, a CAD image of our HYGEN 50. The technology is pretty much known. So reforming, shift, PSA, and hydrogen storage. We use VPSA, so we use relatively low pressure for the PSA, 8 bar, and then vacuum on the off-gas side. And although it's a known technology at the large scales, let's say at our scale, we are quite unique, and there are not many competitors that can offer what we do. These are data sheet. You can download this from our website. The main 3 models that we have now is the HYGEN 50 for 50 normal cubes per hour, 100 and 150. The 100 is actually 150 that has 1 reformer less. That's why the size of the container is the same. So usually people buy all the 50 or the 150, and then are able to turn down the capacity. The nice thing of our systems is they're quite, besides the efficiency, of course, they're very fast to start up. Let's say we can have it on standby and start up in half an hour, or even from fully shut down in 3 hours. And you can, if you're interested, you can download this information also on our website. Here I show you an example of how we usually connect our systems in order to couple it with backup. For example, we can have some number of HYGENs in parallel and compress to 200 bar storage with our own compressors, and then say in the event that the user has peaks of consumption, just take from the backup, or during the moments of maintenance of our systems. We're also able to include compression of natural gas and the compression of hydrogen. This is a layout of how this would be placed on site. We have some nice pictures. Well, this is a CAD picture, for example, of how you could put the 2 HYGEN 50s for 50 normal cubes per hour with the compressors of natural gas, compressor of hydrogen, backup supply, 200 bar storage, and some photos of, well, this is a case in Spain with 2 HYGENs and the storage tanks on this side. This is in Turkey, another situation with 2 HYGENs. This is in Philips. Yeah, this was an interesting case because they also wanted backup, but they're relatively close to us. So for the backup, we just truck in the trailers that we fill at our site in Arnhem. So that is quite handy. This is a customer in the USA. We have in Walmart, actually in more than one location. Walmart, of course, they use a lot of forklifts, and they used to use the battery forklift, but they've seen a lot of disadvantages of them. They need a lot of space for the batteries that need to be charged, and they switched to hydrogen, and they're using just hydrogen filled forklifts for their moving around the shop. And these are a very bad photo of a filling station we have. I didn't find a photo with a better quality, but we have we supply hydrogen for filling stations. Of course, that is not our main customer. Our main customers are industry, but we can supply hydrogen for filling stations, and we have some. I'll say a couple of words on gas recovery technology. This is a layout of the system called Hy.REC mix, hydrogen recovery system, that recovers a mixture of hydrogen and nitrogen from the glass industry, where they create flat glass. So here what you see is what is called a tin bath, where the flat glass is being solidified from melted to the cold end where it's already solid. And they use about 2,000 normal cubes per hour of hydrogen nitrogen mixtures with hydrogen up to 10%. And what we do is we have a piping to our system, we clean it, and we send it back, and we can reduce 50% of the gas consumption in the float, because our system can recycle could recycle a larger flow, but due to the layout of the installation, they can only extract 50% of the flow. But there are no gas losses in our system. The other 50% is just vented in the process itself. So this is an interesting saving technology for the glass industry, and yeah, it's already operational. A zoom on what it does. Pretty much what we had to remove is solid particles, H2S, oxygen and water, and we do that by a set of filtration, desulfurization, deoxidation, and drying via temperature swing adsorption. And yeah, compressor in between is not shown here, but we increase the pressure, of course. Some specifications of what the system does: about 700 normal cubes per hour. It takes in gas at 450 degrees, and then we deliver it back at about ambient temperature. The specs are dew point -60 and 5 ppm of oxygen. And yeah, further you can download information from our website. This is a layout of how it is placed in a container. Yeah, this is also not the best image, but pretty much heat exchanger to reduce the temperature, filter, compress, and we have desulfurization, deoxo, and drying. As a summary, our company, what we do is we supply industrial gas in small bulk. So we're different to yeah, the big players, Linde and Air Liquide, and we are good friends of them, but we're on a different target of market. Yeah, we have the ability to design, install, and operate systems of this small scale. Security of supply, because we can also take care of the backup, and we have lower costs than trucking in many situations. A couple of words about the HAS contracts. This is showing a difference in contracting between buy and gas as a service. Gas as a service is where we put our systems in a lease contract. You see the equipment investment usually, yeah, when you buy is on the customer side, on the HAS contract is on our side. Infrastructural, yeah, this is the same, but the equipment operation is on the customer, but we take care of the maintenance and the service in the lease contract. And for the gas contract, yeah, that they can be done contracts specific on the maintenance and service. The advantage of the lease contract is that there's no financial investment on the customer needed, no additional engineering resources needed from the customer. They can choose which way to go, and no surprises because we take care of the gas supply. And now, with a few minutes left, just a few words about R&D projects. Your project is looking at membrane separation. We have been active in multiple membrane-related projects. Here you see a timeline of different projects. DEM camera, reforcell, ferret, fluid cell. These were projects where we looked at the use of hydrogen separation membranes. M4CO2, you are familiar with it, of course. Some membranes for oxygen, projects with oxygen separation membranes as MEMER and DEM camera we also had there. And now we have two projects still active on membrane technology. HyGrid also uses hydrogen separation membranes, and MEMER, the one Jose Luis just explained about. And what we do in that project is build the prototype systems for two of the three prototypes. Here just some photos of the experience in other research projects: small scale fuel cell system, membrane reformer systems, gas purification PSA. Here we have two examples: hydrogen stripping from fermentation processes, biogas upgrading, and yeah, just some examples I found there. About MEMER, well, this slide you have seen already from Jose Luis. So there are three prototypes, A, B, and C, and we built prototype A and B. This will be in containered, yeah, in containers, small ones, about 10 feet containers. We will place one in Spain, one in Portugal. We are now procuring all the parts, and next year assemble it, and by end of the year send them to the locations. Yeah, this slide you have seen. Say our role is on the prototype manufacturing, and then during the demonstration, all the coordination with the operators. Yeah, this doesn't add too much. I think you've heard already enough about member. These are my contact if you have any question, and you can also send a text through the chat here. Thank you.